All right. Yeah. Let's go. Is this working? Cool. All right. Okay, folks, it's 2:30, so we're gonna get started. Thank you everybody for coming in. This presentation is about providing an update on the state of Godot in XR and Android. We'll quickly start with a small round of intro, but right before, this slide is available on the web. You can use the following link in order to get access to the slide. Giving folks a minute. All right. All right. So quick round of intro. I'm Fredia L Huya-Kouadio. I'm the lead Godot Android maintainer, and I'm also a maintainer on the XR team. Um, I've been contributing to Godot since about 2018. Primarily started on Android, and then I have an interest in XR, so I started contributing to the XR team as well. Since then, I've re-architected a lot of the Android code base on Godot, and in collaboration with the rest of the community, created and start maintaining the Godot Android Editor and the Godot XR Editor.
Hello, everyone. My name is David Snopek. I'm also a Godot maintainer on the XR team. This seems strangely echoey. Does it sound okay to you guys? Okay. I'm also the team lead on the GDExtension team. I'm the maintainer and original creator of Godot's WebXR support, and also an individual contributor on the OpenXR working group. I currently work for W4 Games. We're working on a project with Meta to improve Godot support for Meta's headsets. A big chunk of the stuff we're going to be showing in this presentation is the result of that project. And I also make my own silly little games and tutorials at snopekgames.com.
All right, and I'm Logan Lang, and I am also on the XR team for Godot contribution, and I also work for W4 Games. And then you may also know me from my Godot-centric YouTube channel, where I make some educational YouTube videos related to Godot.
You want that one back again?
One more.
Oh,
Some
technical
difficulties.
Less excitement.
forward or backward?
Forward.
Oh, better?
We got it. We got it.
Awesome.
Like show the QR code for Miguel to have the slides.
We'll go back to it at the end. All right. So we gave a presentation last year at GodotCon 2024. That one was primarily focused on XR and the XR editor. This year, we've decided to expand things a bit and also cover some updates that we bring into Android in Godot 4.4 and Godot 4.5. As a quick reminder, the Android and XR editor share a similar base since they both run on Android-powered platform. So the Android editor was released in 2023. It's available on the Google Play Store, and we also make it available on the Godot download page for folks that don't want to use the Play Store. It's primarily optimized for large form factor, so foldable tablet and Chromebook, but we don't put any restriction on it, so anybody can download the editor on phone or over Android device. Primary support is for keyboard and mouse. We have a little bit of touchscreen and multi-touch support, and we're working on improving the experience and make it better. By Godot 2024, we had about 850,000 devices installed from the Play Store. All of this is data gathered by the Play Store. We don't track user installing the application from other sources. A quick interesting note from GodotCon 2024. The bottom picture is the Android editor running on the smallest Android device that I've ever seen. That device fits on the palm of your hand. That's how tiny it is. That was a device owned by game dev and animator Lucy Lavent, and she was able to show me a full game built and running on that device. I was impressed. So this year, we've now gone to about 1.2 million install from the Play Store. So that's about 265,000 over a 6-month period downloads. We have about 2,000 daily install with about 90K monthly active user. There's a couple interesting observations that we're able to garner from the Play Store. One thing we notice is that Brazil plus India dominate the majority of install. They make about 25% of install of the Android editor on device. Brazil is about 17%, whereas India is about 9%. US by itself take less than 5% of the install. For us, this is a data point about something that we talked about last year, which is that we using this version of the editor in order to lower the barrier to entry of game dev. And this validates our conviction because it asserts that in those countries, developer, they have access to cheap Android device and they make use of those devices in order to do game dev. Since a regular computer or desktop machine are typically more expensive or harder to get in those countries. Another thing we notice is that in the previous slides, we mentioned that we optimize for large form factor device. Users don't really care for it, and about the majority of our install is on phone. So 87% of our install are on phone. So like I was showing in the previous picture, where there's a way, there's a wheel. Or where there's a wheel, there's a way. So those two observations are driving some of our work that we started in 4.4 and work that we continue to do in 4.5. We want to continue improving the user experience and making the experience on mobile better in order to provide the capability and flexibility to develop on phone for the user that need that experience. One thing that's not on the slide because it's way too small to see, but according to the Play Store, over the last 6 months, we had about 53 installed on Android TVs and 15 installed on Android watches. So
Was it the same person on the
that's a good question. I would really love to talk to that person because I don't know what they're doing with the editor on an Android watch. So switching gear to the XR Editor. The XR Editor was released last year, and we made it available on the Horizon Store and also on the Godot download page for folks that want to download it. On the Horizon Store, we limit the editor to running on the Quest 3 and Quest 3S, primarily because of memory and CPU issue, but it's available on the Godot downloads page. So if you have a Quest 2 and you want to install it there, download straight from Godot's download page and sideload onto your device. To date, the XR Editor is the only full game engine running entirely on standalone XR device. And with Zogot announcement today, Godot is the only game engine running on Android, iOS, and XR so far. So from my point of view, that's a unique attribute that Godot only has and no other game engine can provide. So let me play that again. So similar to the Android editor, we have support for keyboard and mouse. We support a bunch of features that Horizon OS, the OS that Power of Request provides. And by this time last year, 6 months ago, we're about 4,000 devices installed on Quest device. By now, we're about 18.5 thousand devices installed with about 2,000 monthly active user and 20-minute average time spent per user. We found the user using the Quest to be an HOSA subset because the Quest has the ability to show the full experience like a desktop. And with the capability that we provide in the XR editor, they can do the full development experience without requiring another machine beside that. So, but it's also an interesting balancing act because we should use the same code base for the Quest and for our Android editor. So when we build feature that share across Android, we need to ensure that the UI on phone, which are smaller, also adapt to the UI on Quest, which is much larger. As we studied last year, though, this is only the beginning. So one of the things that we're trying to do, and one of the things that we announced last year, is that we wanted to bring the XR editor to more device. And so for this year, we're working on bringing the XR editor on Pico OS device. We have an alpha build that's already available on the GitHub release page. We have a few issues that we're still working toward, but the goal is to try to iron those out and release support for the XR editor on Pico device, both Pico 4 and Pico 4 Ultra, either by 4.5 or 4.6. So switching away from the start update, covering some of the key new feature that we're introducing in Godot. So one of the feature that was missing from the Android editor and that was most requested by the community was the ability to export Android binaries from the editor. So prior to Godot 4.4, this final step requires switching to a Linux, Windows, or Mac machine in order to create the binary. So that was a key roadblock to user. And as we saw early, in places like Brazil and India, where using a phone is the primary way of developing, that was a key roadblock. So in Godot 4.4, we removed that limitation, and we made it possible to export Android binaries straight from the Android editor. So this leveraged one of Godot build process, which allowed Godot to download a pre-built template, unzip it, update the data, and then just export the binary for user to install onto the device. Unfortunately, that build process has one limitation, and it is that it doesn't support Android plugin. In order to address that, we're working on supporting Godot build process for Godot 4.5. Logan can provide more info about that.
All right, so I'll just tag in here for a slide. So just wanted to give you guys a quick preview on something that we've been working on, which is doing a Gradle build right on the MetaQuest. So like Fredia said, this is planned to be supported in 4.5. But yeah, I am, as you can see here, doing the process of exporting an APK right on the headset. So there's the editor, the XR editor right there. And then I'm using Termux, which is an Android terminal emulator. And so there are commands that are sent from Godot to Termux, and you can see those being run right there. And there's just a little bit of setup that needs to be granted permission-wise between the two. But other than that, it's fully automated. It installs and verifies other dependencies too, things like Java, the Android SDK. And this is a big deal because it's necessary to actually export an APK that we could run on the Quest if we're using the XR editor, right? And for Android plugins and the sort. So it's exciting stuff.
So going back quickly. Okay. Yeah, so this support, we should be able to bring support for generating pretty much every binary that Godot supports to the Android editor and the XR editor. So that's Android APKs, Linux binary, web export, Ensign Windows, macOS export, and iOS as well. And so we think that's going to be a powerful capability for Godot user using either the Android editor or the XR editor, since they won't need any other device in order to build a full project straight from the phone or XR device. All right. Some of the new features that we're planning from Godot 4.5 in order to improve the developing experience on Android phone. So we adding support for embedded game window in Godot 4.4. This is even more important on smartphone because you have really small screen estate. So the ability to embed your game window and then turning into into a small screen as your development is very valuable. So this use some Android tricks in order to make it work it very well. Unfortunately, those same tricks don't work on standalone XR device. So currently the feature is disabled in the XR editor. But we have some workaround that we're investigating in order to add that support for Godot 4.5. All right. One other set of user requests was the ability to get access to quickly use feature using touch instead of using either the keyboard or using the menu. So we added the touch panel in it's currently in Godot 4.5 dev, so it'll be coming up in Godot 4.5, which provide commonly used capability and make it easily accessible using the touch screen. The feature code followed common Android pattern of providing this capability in the sidebar. And so we'll be using this pattern in order to improve the user experience and keep improving the Android editor going forward. And another set of update is moving the top menu into a navigation drawer, which is another similar Android pattern that we're planning to leverage. This allows us to minimize the width profile of the editor and allow us to start investigating how to support portrait orientation. So we want to give Android user the ability to use the Godot editor in both portrait or landscape orientation. On top of that, we work in, and that's not only of the Android editor, I think that's applied to the entire editor. We work in to update the editor theme and refresh the look and feel by leveraging passive style Godot minimal theme. So look forward to that in Godot 4.5. Last but not least, and that's more for people building Godot game targeting the Android platform, we're updating the engine to generate native debug symbol for each release starting with Godot 4.5. So this has two immediate impacts. One, it gives us the ability to investigate and address editor crashes. This improves the reliability of the editor, which makes for a better user experience, but it also improves the reliability of the engine since the editor is built using the engine, and that benefits all developers targeting Android. For developer, we're giving you the tool that you need in order to properly analyze and investigate crashes in your apps and game. So hopefully this will allow the ecosystem to improve the reliability and stability of apps and game built using Godot. In Godot 4.5, we'll provide documentation to guide developer how to use the feature.
All right. Integrating with Android APIs. So the Android platform has numerous APIs as well as a whole ecosystem of third-party libraries for doing all of the things. Push notifications, analytics, login, ads, etc. These things don't make sense in Godot itself because they are specific to Android, or there are multiple options. There's several different ad providers. Fortunately, Godot has long supported an Android plugin system, which allows you to write Java or Kotlin code that can be called from GDScript or C# or GDExtension or whatever programming language you're using to write your game. This allows creating a Godot interface for any of the Android APIs or third-party libraries. Here is an example. You have to make a class which will be exposed to Godot as a singleton. Oh, first of all, this is Kotlin code, just wanted to call that out, that extends the Godot plugin class, and then you can define whatever methods you want, but any of the ones that have this used by Godot annotation, you can call them from Godot. And any of the arguments will be translated from their Godot types to their Java or Kotlin types, and then a return value will be translated back to the Godot types. There are some Android plugins available. For example, there's a Google Play Services plugin, Google Play Billing, a couple of different AdMob plugins. But there's also plenty of APIs and third-party libraries that don't have a Godot Android plugin available. In fact, this is one of the main reasons that developers cite for not being able to switch to Godot for Android development from other game engines. As we saw in the previous slide, making your own plugin is fairly easy, but it does require writing Java code or Kotlin code and using some other tools beyond Godot, for example, Gradle, or if you want, Android Studio. But there is another way. Java Class Wrapper is a Godot singleton that allows you to interact with Java or Kotlin classes using only GScript or C# or GDExtension. You can, for example, create instances of classes, call methods on them, and check if an exception was thrown. This has technically existed since Godot was open sourced, but it was pretty much broken and you couldn't use it. However, Fredia and I have gotten it working again, improved it a bunch, and now you can use it starting at Godot 4.4. So here is an example. Here we're using the Java Class Wrapper to wrap these named Java classes. The result of this will put an object in these variables that represents the class itself. And then in the second part, we're calling static methods on those classes, which gives us instances of those classes. And then at the bottom here, we're calling a method on an instance and passing one of the other instances as an argument, and it returns a string which prints out the date and time. So not a very useful example, but it does show you that you can interact with Java or Kotlin classes in a fairly natural way. Like we're calling these methods as if they were normal Godot methods and, able to do whatever we like with them. So Java Class Wrapper is great, But to do many actually useful things, you need to access various Android objects, for example, the Android activity. The Android runtime plugin, it's basically a Godot Android plugin that's built right into Godot itself, allows you to access these. So here is an example of that. We have to do engine get singleton Android runtime to get the Android runtime singleton. We have to do it this way rather than just using the bare name because the singleton only exists on Android. Otherwise, you'd get an error in the editor or on any other platforms that you're trying to run your game. Anyway, we get the singleton, and then we can call get activity to get the Android activity, and then we use that to make a toast message. And this is actually a fairly complex API. We're able to take a Godot callable, which is like Godot's first-class function, like a function, a variable, and we can convert that into a Java runnable using the Android runtime plugin, and then pass it into the activities run on UI thread method. So a fairly complex API to use, and we can do it entirely from GDScript. Here's another example. We get the Android runtime plugin. This time we call get application context, get system service vibrator. We can check if that service exists and if the phone says it has that capability, and then we can use that to vibrate the phone. So Java Class Wrapper and the Android Runtime plugin allow integrating with Android APIs without switching away from GDScript or using any other tools aside from Godot. I personally think this is going to be huge for adoption of Godot for Android development. If you only need to do something simple or use a small part of a third-party library, you don't have to make a plugin. Or you could make a Godot add-on that uses only GDScript and Java Class Wrapper and upload that to the Godot asset library, and we can start to hopefully have more integrations available. All right, let's change gears completely. We're going to talk about various OpenXR improvements in Godot core, both some that were already released in Godot 4.4 and some that are coming soon. A lot of these topics are unrelated to each other. I'll try to signpost when we're changing topics so it doesn't get too confusing. But before we do that, a tiny bit of context about OpenXR and Godot. OpenXR is a cross-platform open standard for VR and AR. It's supported by pretty much all of the hardware vendors except for Apple. Khronos is the standards body behind OpenXR, as well as a bunch of other open standards that are important to Godot, like Vulkan, OpenGL, and GLTF. Godot has support for OpenXR built into Godot itself. It's not just a plugin, like it is in some other game engines. OpenXR is made up of a core spec and extensions. All OpenXR runtimes will implement the core spec, but extensions are optional. Those extensions come in a bunch of different groups. The first we'll talk about are KHR extensions. KHR is like the prefix in front of the name of the extension. These are extensions that were agreed upon by everyone in the OpenXR working group, but they're optional, so they're extensions. Then there are EXT extensions. These are multi-vendor extensions. They're created by 2 or more vendors working together. And finally, single-vendor extensions. These have a prefix like the vendor names, like Meta or BD, that's ByteDance for Pico. And these are very important because there's a lot of innovation going on in the XR space, and this allows vendors to make the unique or new capabilities of their device available to developers before there's been time to work out a standard with the rest of the vendors. Anything from the core OpenXR spec, KHR or EXT extensions are allowed in Godot itself, but single vendor extensions should be added to the Godot OpenXR vendors plugin. This plugin is maintained by the Godot XR team, so the same people that are maintaining XR support in Godot itself, but we made the decision to separate single vendor extensions out into this plugin. There are some exemptions. Some single vendor extensions may be added to Godot if it would be technically infeasible or impossible to do from a plugin. So that's why you may see some in Godot source code. The Khronos Godot integration project. Bastiano Lee, our fearless leader, the lead Godot XR maintainer, is sponsored by Khronos to work on the Godot integration project. This project has a couple of different goals, one of which is filling in the gaps by integrating support for KHR and EXT extensions that we didn't previously support. And the other is adding support for new extensions before they are publicly released. And this is great for both Khronos and for Godot. For Khronos, it allows them to test the extensions and also to provide a reference implementation. So if Unity implements one of these OpenXR extensions, great, but nobody can see that code. If Godot implements it, that code is available to the world, and anyone can go and see how would this extension be implemented in a real game engine. And for Godot, it allows us to have support for the latest features on day one, maybe even before the other game engines. So unfortunately, we can't really talk about what Bastian is working on with regard to these not yet released extensions, because that's all confidential. But Fredia and I are both members of the OpenXR working group, so we can see his code in a private repo, review it, test it, and the day that these extensions are published publicly, Bastian can make a PR and we can fast track it into Godot. Changing topics entirely. Composition layers using an Android surface. So composition layers in the context of Godot are like floating panels, either flat or curved, that have 2D content rendered onto them from a Godot subviewport. This is something we added in Godot 4.3 and we talked about at the last GodotCon in Berlin. There's a bunch of different reasons why you might want to use a composition layer, but probably the most common one is that it provides sharper detail, especially with text or UI, than if you were to do the same thing with like a Godot mesh instance and a viewport texture. The new thing is that now you're able to get 2D content not only from a sub-viewport, but also from an Android surface. This was added in Godot 4.4, and to call back to an earlier part of the presentation, it uses Java class wrapper to return that Android surface to Godot. There's a bunch of different things you could use this for. Really anything where you want to use the Android APIs to do the drawing. So you draw it to the surface, and then it gets presented on the composition layer. But some examples are showing Android UIs, showing a web view, or playing a video, taking advantage of any hardware video decoders that the device might have. I've made 2 example projects showing that video playing use case, one using a Godot Android plugin and another using purely Java class wrapper. And here is a video clip from that. You can see me moving my cube hands. And then in the back is just a couple seconds of a video playing. Another entirely new topic. OpenGL versus Vulkan Mobile on standalone VR. So we currently recommend using the OpenGL renderer on standalone VR. One of the main reasons is poor performance with Vulkan Mobile. Here are some benchmarks. So this was done with a modified version of the GDEquest TPS demo. It basically fixes the camera in 3 different spots in the scene, that's what the 3 markers are, and records some statistics. We can see on OpenGL on marker 1 and marker 3, we are at frame rate. That's our goal, 72 FPS. That's what the display is running at. On the second marker, we're dropping some frames. We're not quite making it to frame rate. Vulkan Mobile, though, does a whole lot worse. On the first 2 markers, we're getting only 36 FPS, and on the third, it's getting up to only 60 FPS. So what is the reason for this? Well, a couple of things. But the biggest is foveated rendering. Our OpenGL renderer supports it, but Vulkan Mobile didn't until now. So really quick, what is foveated rendering? So the eye sees more detail at the center of your vision and less detail out in your peripheral vision. So rendering optimization that we can make is having a higher resolution at the center of your gaze and a lower resolution on the outside. You can't see all those pixels anyway, so why bother rendering them? Here's an example trying to show that. The area in the middle is the high resolution area, and then around the outside is the lower resolution where it looks a little more pixelated. So Godot has long supported foveated rendering in OpenGL, and it has even supported it in Vulkan with the fragment shading rate extension. However, on mobile, this extension either isn't supported or doesn't provide nearly as big a performance boost as we get under OpenGL. However, coming soon in Godot 4.5, due to amazing work by rendering legend Dario Samo, we will support the fragment density map extension, which provides massive performance gains. So here's those same numbers again in these first 2 columns. This one is the Vulkan Mobile renderer without foveated rendering, and here it is with foveated rendering. On the first and second marker, or first and third marker, On the first and third marker, we are getting almost a frame rate, 70 and 71 FPS. And on the second, we're still not quite up to what OpenGL has, but quite a lot better. And we're going to keep working on rendering optimizations for the Vulkan mobile renderer, specifically targeting the Quest, but it will actually benefit any hardware that uses the Vulkan mobile renderer, such that hopefully, maybe, by the time Godot 4.5 comes out, we will actually have managed to close that gap and could start recommending the Vulkan mobile renderer. Do we have time to talk about? All right. You guys are getting the long version, the director's cut. All right, so OpenXR binding modifiers. This is an extension implemented by Bastian as part of the Kronos Godot integration project, not the super secret unpublished stuff, but the filling in the gap stuff. This was included in Godot 4.4, but to explain what it is, you will need some background. We'll have to talk about the OpenXR action map system. So what is that? It's similar to Godot's input map system. It allows to make named actions and bind them to specific inputs on specific XR input devices. So for example, we could make an action open menu, this is a name we give it, and bind it to the user hand left input menu click button. This is the menu button on the left controller on an Oculus Touch controller, identified by this path, and then on this particular interaction profile, which represents an Oculus Touch controller. But why do we even need this? We have an input map system in Godot. Well, input is still an unsolved problem in XR. There's a lot of innovation happening now, and there's going to be even more innovation happening in the future. Some far future possible things, gloves like Ready Player One, that would be awesome. A neural wristband, Meta's been working on this for years. It's basically like a band that you wear that can detect the nerve signals going to your fingers to allow you to do input with very tiny motions. People even say that once they really get used to it, they're able to trigger the input without actually moving their fingers. It's like mind control. And then hand tracking only headsets. I don't know if there's any OpenXR hand tracking only headsets, but the Apple Vision Pro is hand tracking only. It's inevitable that there will be hand tracking only headsets for OpenXR as well. So how does the action map system help with this? So the app is actually only giving suggested bindings for specific controllers. The OpenXR runtime may automatically map from what we give it to a different controller, to the controller that is actually attached to the headset. So for example, if the app gave bindings for Quest 2's controller, but it's actually running on a Pico 4 with Pico 4 Ultra controllers, the runtime will map what it knows about the Quest 2 controller to the Pico 4 Ultra controller. The headset may even use controllers or other input devices that didn't even exist when you created your app. You can give, suggested bindings for every controller you know about, but in a couple of years, there will be new stuff. There'll be new controllers, new input devices. And the OpenXR runtime may also allow the user to change the bindings for their specific input device or situation, which is important for accessibility. However, all of this only works when all of the input configuration is exposed to the action map and not hard-coded into the app itself. Binding modifiers allow us to expose more stuff to the action system. For example, let's say you have an app using the thumbstick like a D-pad for navigating UIs. So you move the D-pad, or you move the joystick to the right to move focus to the UI element to the right. The thumbstick itself is bound via the action map system. This is part of the core OpenXR spec. But you may have angles or thresholds hard-coded into the game itself. Like how far do you have to move that thumbstick to the right for it to be considered pressed? What angles are considered to the right and not upright? So what if you hard-coded thresholds or angles for a thumbstick on one controller that's actually impossible or very, very annoying to reach on another input device? Like, what does it mean to use a thumbstick with a neural wristband? And how easy is it to hit all those different angles, right? Binding modifiers allow us to expose these things, like angles and thresholds, to the action map, so the OpenXR runtime can automatically adjust for that. We're able to tell it our intention, and then it can say, what is the best way to satisfy that for the actual input devices that are attached to this headset? Or allow the user to manually change these things via settings. So this is a screenshot from Godot 4.4. We're adding a D-pad modifier to an OpenXR action map. You can see we're setting the threshold for how far you have to move into a direction to consider it pressed, how far back you have to move to consider it released, and how we are breaking up the area around the thumbstick to decide what the directions are. And once you've set this up, you just listen for D-pad up, D-pad down, D-pad right events, and you get all of that OpenXR magic.
All right. So we cover the Android and the XR Editor, and we just cover updates to Godot core base. So now we're switching gear to the OpenXR vendor plugin. And to reiterate what David stated, all the core and exe extension go straight into Godot core. Any vendor-specific extension goes into the vendor plugin. This is how we support the rest of the community by making sure that all the capability and functionality is available. Vendor plugin is also an MIT open source project, so community is also free to contribute to that as well. And we just released version 4.0 of the vendor plugin. This release includes a bunch of features that we're going to cover in the following slides. First but not least is we adding support for hybrid app to Godot 4.4 coming with version 4 of the vendor plugin. So a little background about hybrid apps. Hybrid app were introduced in late 2023, and the app that can run both in panel flat mode or in immersive mode, and they're able to transition between each mode at one time. So a good example of that is the YouTube VR application on the Quest app. You can start the YouTube VR application as an immersive app, and whenever you wish, you can switch that to a panel mode. This gives you the ability as a user to run applications side by side, which allow you to multitask between multiple applications. Or in immersive mode, the app experience is the sole focus and the user is fully immersed into it. Another example of hybrid app is the Valve Steam Link application and also the Godot XR Editor. Why would developer want to build an hybrid app? There's a few benefits to doing so. One, it allows developers to easily add immersive support to their existing app and games. We have a huge library of existing 2D flat game, either running on PC or running on mobile. And with hybrid app, you can take your existing game and add immersive capability very straightforward. You can leverage your existing code base and logic. You don't need to write a project from scratch. And it allows you to give user multiple interaction modes. So certain users are not so fond of immersive application because it gives them motion sickness. Those users can switch to a panel version of your application. Whereas other users only want immersive application. If you go on the Meta store and you look at some 2D, some flat apps or game, a lot of them are bad reviews because some users don't see the point of them on an immersive headset. And so with an hybrid application, you can provide support to user and they can configure the experience as they wish. People that don't like immerse can use the panel mode. People that don't like panel can use the immersive mode. So it gives you flexibility as a developer. So the Godot editor has been able to use this capability since last year. And in 4.4, we're making this available to all Godot developers. So within the Godot editor, you're gonna have the ability to build an hybrid application. We're providing cross-platform support for all Horizon OS device. So Quest 1, if you want to, Quest 2, Quest 3, Quest 3S, and Quest Pro. And we're working towards support for Pico device. This capability is built by leveraging Android's API as well as OpenXR. So we expect to be able to add support for other OpenXR device coming in the future. One of the nice benefits of this feature is that the ability is dynamic based on the target platform. So you can use the same Godot project, can run as a regular flat application when exported to a regular Android device, and it can run as a full hybrid app when exported to a standalone device. So it allows you as a developer to target multiple engines, target multiple platforms, Android, Horizon OS, Pico OS, and target multiple store, Play Store, Horizon Store, Pico Store, with the same project. As a potential use case, based on our experimentation and from the learning from folks like YouTube VR, you can either build an hybrid app that mirror content between the panel and the immersive mode, This is what YouTube VR does, where you can play video in a flat mode or you can play video in an immersive mode. Or you can build an hybrid app that performs the initial setup in panel before switching to immersive mode, which is similar to what Valve Steam Link or the Godot XR Editor does, which the flat mode is used in order to configure things, and then the immersive mode is used to enjoy the full experience. We made it very simple for Godot developer to get access and use the capability. So within the editor, you just go to the project setting, enable the feature, and select your launch mode, whether your app should launch by default in panel or whether your app should launch by default in immersive. And as a reminder, this project setting is a no-op on platform that don't support that. So even if your project is running on a regular Android device, you can just leave it enabled. And whenever you target requests or over standalone XR device, the project will behave as expected. And in your code, all you need to do is call the following couple of API. So when you're switching from one mode to the other, your application is restarted. In order to do the switch, we provided a switch mode API that allows you to specify which mode you want to switch to and allow you to pass data between the modes. So if you want to store the current state, let's say the user wants playing a game, he has a specific store, a specific position, you can store that and pass that as a second argument. When your application is restarted in the other modes, the application should be able to retrieve the data using the getLaunchData API and restore the current state of the user. We have some additional documentation and sample on GitHub, so feel free to take a look and provide us with feedback. This is the first iteration of this capability, so we're looking forward to what the community think and any additional capability APIs that could make your life easier when it comes to creating an hybrid application. All right.
Okay, so I'm going to walk through a couple other extensions that we've implemented in the vendor repo. So the first one is dynamic resolution. And this is a meta OpenR extension that dynamically recommends render target resolution. So that means that it allows the runtime to help preserve a higher FPS at the cost of graphic fidelity. So it's basically prioritizing playability over visuals, which is a good thing because like low FPS is a recipe for motion sickness, and I don't want that in my VR games. And this is queried every single frame to allow for smooth transitions between changing resolutions, so it's not incredibly jarring. It is a noticeable change in resolution when the CPU or the GPU is under a very heavy workload, but it is still very much a very worthwhile trade-off, as I'll show an example here in a second. But yeah, it's very simple. It just needs to be enabled in project settings, and it just works. And it's enabled by default because it kind of makes sense that you'd probably want to use this in all of your XR projects. So just as a little example here, in this demo project, this is a zoomed in picture, but this is a view that really causes the renderer to hitch a lot, and 36 FPS is unforgivable. But if we have dynamic resolution on, it magically just hits the target FPS of 72. And it's a noticeable change, but I think it's a worthwhile trade-off. Okay, another extension that is coming in 4.5 is Application Space Warp, which is probably the coolest name for an extension that's ever existed. And so Application Space Warp is a meta OpenXR extension that allows applications to render at half frame rate while the runtime generates the in-between frames. So rendering at half frame rate provides apps with a much larger computation budget, which Meta estimates to be about 70% extra. And I'll explain how it does this in a second. But Meta has this little image that I stole from their docs to illustrate this, which is, so when you're rendering at 72 frames per second, you have a theoretical blue rectangle of computation budget to use. But if you only have to render half of them, that budget theoretically doubles. So you get a bigger rectangle, but 30% of that is estimated to be used by the Application Space Warp overhead. So how does Application Space Warp work? I'm glad you asked. here's another image from Metastox on it. So the color eye buffer, this is just what you would see in the headset, and the other two textures I'll talk about right here. So Godot provides two textures to OpenXR, along with some other data, to help generate the in-between frames. So the one up top is a motion vector texture. And what that is doing, it is essentially calculating the motion between every single two frames, and it is mapping the X displacement, Y displacement, and Z to R, G, and B. So essentially, that image on the right, so you can see the blue on that rectangle in the middle, that means that it's moving in the Z direction with regards to the camera, and the green means it's going up. It's not a perfect visual representation because it's -1 to 1, and if red was -1, you can't see that, but you get the idea. And then we also submit a depth buffer, so it knows what is in front of what else. And the texture resolution is provided as a recommendation by the runtime, and it's usually a very small resolution. I think on the Quest 3 it's like 440 by 440 pixels, so it's very easy to render. Yeah. And application space warp is a very powerful but not perfect solution for every scenario. Some of those scenarios being if you're using transparent materials, those are not included in the motion vector texture, so that can cause some artifacts. So you don't want to use it with those. If you have a very high resolution detailed texture and you're moving stuff in front of it, it can cause some blurring on the texture behind it. Now, it has to be very detailed, very high resolution. I think in most situations you would not bump into this problem, but it is there. And if you have non-smooth movement, like if you have objects teleporting around, it doesn't work very well because it causes big smears. Application space warp is meant to be used with smooth movement, but application space warp can be switched on and off or disabled on a per frame basis, which means for teleporting movement, which I have to use because I get motion sick in VR, still works well. So on the frames where you are teleporting, you can just disable it for that frame. And this is coming in Godot 4.5. All right, another extension that we've been working on is the Meta's Depth API. So this is a Meta OpenXR extension that provides a real-time depth map, enabling the dynamic occlusion of virtual objects by real-world surroundings. And that is an extremely useful thing for mixed reality apps because before having an extension like this, if I have something in a virtual space and let's say you have a dog that runs up to you, well, your virtual object is going to be in front of that dog. I wish I had a dog. I could have put it in this video. But that's not very immersive, right? We'd like the dog to be able to be in front of the cube. And yeah, that's extremely useful. And this can be used alongside the scene API, which is what you might use to occlude things in your static environment. But this just makes it available for dynamic things as well. And we have a working implementation of this, but we still need to determine the correct way to go about the implementation. But hopefully we will see this in Godot 4.5. Okay, we're in the home stretch, folks. We're almost done. So last but not least, the Godot Meta Toolkit. So this is another GDExtension plugin that exposes Meta's platform SDK and some other tools for XR development on Meta devices. And we released this back in February. So first of all is the platform SDK. So Meta's Platform SDK is a toolbox of features to help developers creating VR apps on Quest. So this would expose things like achievements, leaderboards, friends, and more. It exposes in-app purchases and downloadable content, user authentication and entitlement. And the Godot Meta Toolkit plugin provides all of this in an easy-to-use GDScript API. And it's created using code generation, which helps with keeping up to date with it and makes it so that it's less work for us to keep that up to date. So here is just a super simple example on how this works. So I just made a function here because I wanted to see how many friends I have. And so it's just very simple. You just await the completed signal from a function that calls the friends list, and then you just check if it errors out, and then I'm just going to print them out, and hopefully I have some friends. And if you want to learn more about this, we have a nice getting started doc page that you can visit. All right, and then the Meta XR Simulator configuration tool. So the Meta XR Simulator is a tool for testing VR apps on desktop, which is very useful for faster iteration times because if you're testing something simple, it's very painful if you want to work on something, put it on, take it off, work on it, and put it back on. So this just provides you with a way to see what it might look like just on your desktop, so you don't have to do that. And this is just something that the plugin provides to simplify that configuration so you can use the Godot editor to do that. So all you need to do is just download it, follow the steps. You just take a file path, stick it into a prompt that's given by this tool, and then you just have to select the XR runtime that is then provided, and it just works. And I think that's all we've got.
Thanks, everyone. If you are here, I guess we'll show this first. So this is a trailer for an upcoming Godot VR game, Penguin Festival, a social multiplayer experience. Looks like it's going to be very cool. We're just going to let this play in the background while we are doing... Oh, how do you do a right click on this? Is it two fingers?
Yeah.
There we go. We're going to let this play in the background while we do questions. Also, if you didn't get it earlier, we'll show the slide again that has the QR code to get the slides if you want. We have lots of cool links in there. Does anyone have any questions?
So, as someone that is not familiar at all with any of this and was here for curiosity, seeing that you can wrap Java stuff within Android, does that technically mean you could also wrap Java stuff on desktop?
No, unfortunately. So we're interacting with the JVM that has loaded the app on Android. There is a GDExtension binding for the JVM that you can use, and there you could, on any platform on the desktop, write Java code and have it interact with the Godot APIs.
Can you repeat the question for me?
Oh, sorry, I did not repeat the question. The question was about if you can interact with Java stuff from GDScript on Android, could you also do it from the desktop?
Oh, Jojo, do you want to talk about that? Yeah. Okay. I was gonna add, and feel free to follow with Jojo after that because he has some info about that. We have some contributors that are working on providing JVM binding to Godot. So when you can write Godot game logic using Java or Kotlin, so that might address part of what you're looking for. I think once that is available and ready to be integrated into core, we will need to see how this integrates with Java class wrapper. But I think that will be another mechanism to use Java on the desktop. Sure.
Since you're using the motion vector texture or motion vector texture in the application space work, is there also other plans to expose it also for user shaders as well?
What's up?
Can you repeat the question?
Oh, so the question was because the motion vector texture that's being used for application space warp, is that something that's going to be exposed for just Godot developers to use in general? And I believe the answer to that would be no. I don't think that's something that's exposed for people to use. It might be in the forward renderer.
I don't think it's presently.
Is the Uber shader that the forward renderer uses for most of the when you do Godot shader, basically it's compiled and inserted into that, and actually somebody's been working on it anyway.
But actually, I think it is available actually to grab from, is it the XR interface?
Yeah, you could grab it from the XR interface.
Yeah, so
Timing issues with that, though.
yeah, so it's not really possible, but
Yeah, I would say if the rendering team decides they want to expose that in general, then we would also for the Vulkan mobile renderer. I don't think they've exposed it in Forward Plus because there's also motion vectors in Forward Plus.
Yeah, it's in there, isn't
Mhm. Yeah, I think that'd just be a matter of making a new constant that lets you refer to that texture, probably. But yeah, that's more a question for the rendering team.
You have a use case in mind for the capability?
Like there's some data motion effects that you, or like blurring that you can only do with like those captures.
Yes.
Does that or the fact that you can now export APKs on Android or XR, is that going to simplify or change the Android export process from desktop at all?
Yes and no. Thank you. So the question was whether the ability to export Android binary on the Android editor and XR editor would simplify the process of doing so on desktop. So the primary, we've been trying to improve the experience on desktop. The primary issue that we run into is the Android SDK require a user license to be accepted by the user. So we cannot really automate that process. And so that's been a huge pain point. We've been talking with Google, trying to figure out if there's ways we can go around that. Conversation is still ongoing. The other thing, the other area where we could make things easier, it will be to bundle a JVM within Godot in order to make it simple so users don't have to download the thing. Here we run into some users have multiple JVM installed and they want to use those JVM instead. So we will need to support both options where we provide you with a bundle that we automatically download for you, but we also let you specify your JVM if you want to do. So we're still looking into doing that. Definitely not for 4.5, but that'll be coming at some point within Godot. Yes?
Yeah, I was interested in the action mappings concept, and I was wondering, the examples you gave were all kind of like hardware inputs, like a joystick. I was wondering, is there any abstraction for like physical gestures?
Yeah, so the question was about the action map stuff, if there were any abstraction for physical gestures. So yeah, there is an OpenXR extension that makes an interaction profile just like a controller, but the buttons on it are like hand gestures, which we already do have support for in Godot, I think maybe since 4.3 or 4.2, something like that. Bastian did that work. But yeah, that sort of thing exists. The system is very abstract. It could cover body motion, or I don't know, anything you could think of could be represented in the action map system.
The question about the foveated rendering stats that you put up earlier, is that some sort of static type of foveated rendering, or are you using an eye tracking headset to get those statistics?
So the question was, are we doing dynamic foveated rendering where we're using eye tracking, or static foveated rendering? So what we've been working on recently is just static foveated rendering, or fixed foveated rendering, I guess is the term. So you assume that the user is probably looking in the center, and so
The actual forward depth, right? Like the headset?
yeah, I mean, we're just looking at the center of the lens, or actually what we're looking at is whatever the OpenXR runtime gives us. We're asking the OpenXR runtime for a fragment density map, and it gives us what it thinks is the most optimized for the headset. We do technically sort of support eye-tracked foveated rendering, but only under really specific conditions. Like if you're on PCVR and you're using a headset that supports a specific OpenXR extension, and you have a graphics card that supports a specific Vulkan extension, we also get that. But that's yeah, very limited. The plan is definitely to add support for dynamic foveated rendering in the future.
On standalone XR, I think the Quest Pro was the only headset that had eye tracking. So back then there was a Quest Pro extension in order to support the capability. OpenXR device.
There is an open source OpenXR implementation for Vision Pro.
Check that out.
Yeah, yeah. But yeah, I think Quest Pro has been deprecated. So at this point in time, there's no device that support out of the box eye tracking OpenXR. The moment there is, we'll be adding support for that. Yes.
What do you recommend is the workflow for users for getting projects onto and off of the Quest Pro if they're using the XR editor?
So the question was, what's the recommendation for user to getting projects on XR device if they're using the XR editor? So we put together a quick tricks page to recommend. Right now, Git will be the best path forward. So use something like Termux emulator. It has Git command access, so you just set up Git event it runs. That's how I develop both on my Quest and also on my Android phone. I have Termux installed on both of them, and I just sync my project back and forth.
I just teach it with a lot of kids, so I'm wondering if there's like a more GUI-centric way to get.
There are GUI ones. There's like
Android Studio.
mgit.
Okay.
No, on the device.
Oh.
Yeah, there's mgit on the device that you can use. We're all programmers, so we're gonna go for the command line. But there are things available.
That's something we're looking into. I think the trick here is how much we rely on the platform versus how much we build ourselves. Because ideally, if a Quest wanted to be like a desktop computing platform, it should provide those capability. In the meantime, we talked about building those, which is, as you can imagine, building the UI is a lot of investment. So we're still considering that. I think it will be based on the expectation that we get from users.
Thanks, everyone.